I'll turn the recording on now.
All right, make sure everybody can see that before we start. No, is it sharing? Just want to make sure.
Yep, looks good.
All right. All right, let's just hop into it. Hi, everybody. So my name is Stephen Vaughn. For most of my adult life, I've just let life take me where it will. Floating through life, never really deciding on my future unless I didn't have a choice, but to make that decision. At the beginning of 2022, my life was shattered due to losing my father, mother, and my grandparents within a month of each other. In the aftermath of these tragedies, I decided that I no longer wanted to take the easy path that life was putting in front of me. Through this revelation, I started to evaluate what I wanted to do. Now, I've always had a love for math and technology and wanted to find something that would bring those together. This led me to finding cybercoders and starting my journey to become a data analyst. So I don't know about you guys, but I've always loved looking up at the night sky and letting my mind wander what's out there in that big black void. Well, apparently, there's a bunch of big rocks flying around out there, zipping by us at crazy speeds. Which led me to do my capstone on near-Earth asteroids, NEAs, near-Earth objects, NEOs, and potentially hazardous asteroids, PHAs. I'm going to say those acronyms a lot, sorry. The biggest question I had about these three categories of asteroids was just how many are out there and do they pose a threat? Let's move on to the next slide here. So I found two different websites that you see here. The International Astronomical Union Minor Planet Center. From the IAU, I got the bulk of my data set. The IAU is the biggest database for NEAs and NEOs. It takes data from observatories all around the world. And once they have multiple observatories send them the same information on an asteroid, and then publishes that data in its database on a daily basis. The second source I use comes from good old NASA itself and its Center for Near-Earth Objects. The majority of near-Earth objects have orbits that don't bring them very close to Earth, and therefore pose no risk of impact. But a small fraction of them, called potentially hazardous asteroids, require more attention. These objects are defined as asteroids that are more than about 460 feet or 140 meters in size, or with orbits that bring them as close as 4.6 million miles of Earth's orbit around the sun. Now, to get a little perspective on how far away that is, the moon is about 239,000 miles away, and our nearest planetary neighbor, Mars, is 71.9 million miles away. So not all that close in relative terms. So now that I found my data, it was time to start writing my code. To clean it up and to get it into a format that I wanted. See, these pictures here show code that was used to remove extra white spaces that was in between my columns and then turn all that white space into commas. So I had a nice CSV file just in a text document. So I also used Python to turn these files into a CSV file and then combine all of them into a master list Excel file that had all my data sets on different pages along with a sheet combining them all into one data file. I also use Python to find how many asteroids were found per year and then enter that data into my combined Excel spreadsheet. After doing that, leads us to my first graph here. So this slide shows how many NEAs and NEOs that we have found per year starting from 2011. Starting from 2011, there's been almost 22,000 found. As you can see, as technology and our understanding of astrophysics and astronomy has evolved, we have found more each year. Right now, NASA believes they have found around 90% of all NEAs and NEOs over a kilometer in size and has switched their focus to finding the NEOs that are larger than 140 meters, which is about half the height of the Empire State Building. In total, NASA has discovered 30,026 NEAs and 30,143 NEOs. This was as of October 4th of this year. Of these, 12,308 are over 100 meters, which is about the height of the Statue of Liberty. with 856 of them being over 1,000 meters, which is twice the height of the Empire State Building in diameter. We will cover why these numbers are important in a later slide. Next up, we have a graph on what is called the Palermo scale. This scale shows the potential impact risk of asteroids. Now, a scale value less than -2 reflects events which there is likely no consequences. Values that are between -2 and 0 show asteroids that merit monitoring, and PHAs with a positive value are situations that have some level of concern. So a Palermo scale value of -2 is only about as 1% as likely as a random background event happening. Now, a random background event is an event that cannot be stopped or avoided. Our only course of action is to bear that event. A 0 indicates the event is just as threatening as any background hazard, and a +2 indicates an event that is 100 times more likely. As you can see, there's no PHAs that we have found that pose a real threat. Next up, we are going to do a little history on nukes for reference on the destructive power that asteroids had if they do hit the Earth. In this image, you can see a representation of the nuclear weapons that have been developed and deployed. The Fat Man was a 21 kiloton bomb dropped on Nagasaki during World War II, and we have all seen the effects it had on the people and the city. The largest bomb ever developed and deployed was the Tsar bomb. It was a 50 kiloton nuke. Now, the plume from this explosion breached the stratosphere and reached a height of over 37 miles, roughly 6 times the flying height of a commercial aircraft. Little side note on the Tsar bomb is that it was initially designed as a 100 kiloton bomb, which is crazy considering the Red Bull guys that jumped from the stratosphere. The Tsar bomb at the 50 kiloton was actually, the plume was higher than where they jumped from. If they would have dropped it at the 100 kiloton bomb, it would have been 4 times larger than any other bomb that was ever tested. Now that we have some idea of the largest man-made WMDs, we can compare those to the impact force of possible PHAs. So a small disclaimer, NASA does not have an exact size and composition of PHAs. For the size of a PHA, it is common to use the volume equations of a sphere to calculate the impact force. As for the composition for its density, I went ahead and used iron as the main element that the PHAs are made of. That being said, these calculations are more destructive than the actual impacts would be due to these variables and the fact that a large portion of these asteroids would burn up entering our atmosphere if they did not completely disintegrate while doing so. Due to these factors, most PHAs, even if they do hit Earth, pose a small risk. It's not till we start getting to around 90 meters and up that the destructive power of these PHAs start to become a threat. The largest PHA that we have found so far is an estimated 2,000 meters, or about 1.24 miles, with an estimated impact force of 69.1 quadrillion kilotons of TNT, or the equivalent to about 1.34 trillion Tsar bombs. Or, it's a Earth killer. It's an extinction level event. But at least it's a negative 4.59 on the Palermo scale, so virtually no chance that it'll hit. Besides, it won't pass Earth until September of 2111. So we're good. So following learning about the destructive power of the PHAs, it made me want to know what exactly humanity is doing to try and stop them. Ironically enough, unbeknownst to me, we had already started working on ways to do this. On September 26th of 2022, history was made with Earth's first attempt to change the trajectory of an asteroid. The name of that mission was Drought, the Double Asteroid Redirection Test, in which NASA used force, which just means they rammed a spacecraft into it. The top picture is one of the last images that the Drought sent back, is of the surface of Dimorphos, which is an asteroid in geosynchronous orbit around Diomas. The object of this was to transfer the momentum of the dart, which was going around 14,000 miles per hour at the time of impact, and use it to slow the speed of Dimorphos, this changing its orbit around Diomas. If it works, it will prove that the smaller PHAs could be redirected around Earth using this method. It will still be several weeks till Dimorphos finishes its orbit around Diomas, and we can see the results. This next slide shows the moment of impact as seen from the Lucia cube that the dart carried with it. I just thought that they looked pretty cool, and it's pictures of history being made. The next slide I have for you shows the dart's final moments before impacting Dimorphos. So this is a 15-second video of the dart's final flight. The video has been sped up to about 10 times its normal speed, except for the final 6 shots that are in real time. Go ahead and start that. Besides force, there's a couple more ways to change the trajectory of an asteroid. Ironically, the movie Armageddon is apparently a viable solution. We can send a team up, drill a hole, and drop a nuke down it, either splitting the asteroid into smaller chunks that either burn up in our atmosphere or get completely blown off course away from Earth. If the explosion doesn't break the asteroid apart, the force caused by it could be channeled to push the asteroid off course as well. The last solution I ran across was just landing a spacecraft on the asteroid and firing the engines to push the asteroid off course. At the end of all this, most PHAs pose no threat to the planet Earth, and of those that do, by the time they come close, the next 100 years or so, humanity should have an answer for them. That's not to say that we don't need to keep watching the stars, though. Just 2 years ago, in 2020, we recorded the closest flyby of an asteroid to date, just 1,800 miles away. It's about half the width of the United States. This asteroid was going over 27,000 miles per hour, and we discovered it 6 hours after it had flown over the southern Indian Ocean. Now, granted, this asteroid was a little larger than your average sedan and would have burned up in the atmosphere had it entered it. The reason we missed it was because it came from the direction of the sun, so we couldn't see it, which is currently a huge problem for observatories. Not only do we have celestial bodies that block our view of asteroids, but there's currently a lot of man-made ones as well. We currently have Starlink that plans to launch around 42,000 satellites into orbit, with other large companies following suit, such as Amazon. We also have companies like AST Space Mobile that just recently launched and deployed a satellite so large that you should be able to see it with the naked eye from Earth. So simply put, as long as we keep watching the stars and consider what we put in the sky around us, we don't need to worry about PHAs anytime soon. As for how many are out there, there's enough that even though there's a very small chance of one hitting Earth, it will be worth every penny humanity will ever spend in building and maintaining the infrastructure we will need to keep monitoring the skies above. Not to mention, in doing so, we get some wonderfully beautiful views of the celestial bodies and planets that are out there. So that is the end of my presentation. I will be putting my Tableau link and my LinkedIn link in the chat for everybody. But before I end, I just wanted to say thank you to everybody for coming tonight, as well to Savvy Coders and the LETC program for this opportunity to better myself. So thank you.
Fantastic. And
Great
those
job.
photos from the James Webb were a really nice touch. They're incredible photos. Any
They're
questions
absolutely beautiful.
for Stephen? Did anyone have any questions? I'm glad we don't have to be worried about an asteroid destroying life as we know it in our lifetime. Really good findings from your presentation, unless it comes from the direction of the sun.
I just like to say thank you. It really educated me on a lot of things that I didn't know. So
All right, and with that, we will jump into Holly. Holly, you're on mute.
I know, I was just setting up everything.
All right, getting ready.
Thank you. Okay. So, hello, my name is Holly Robinson. The name of my project is Scraping Motivational YouTube. To tell you a little bit about myself, 6 years ago, I didn't know what I wanted to major in. So I tried different intro courses and fell in love with engineering. Unfortunately, at the time, my math scores wouldn't allow me into the College of Engineering, but I kept going forward and I got my analytical skills by researching human behaviors through my Bachelor of Science in Psychology with the emphasis in mathematics. So I want to give a special thanks to the LETC and Savvy Coders for allowing me to have my start in tech today. Before I get into my analytics, I want to go over a few vocabulary words with you guys. So the first one is shorts. So shorts are videos with a duration of 60 seconds or less. This is a relatively new YouTube feature in competition with TikTok and Instagram Reels. Another vocabulary word is live streaming. So this is a video sent over the internet in real time without first being recorded or stored. In my analysis, live streams or lives will be referred to as having 0 views. This is because of how I scraped the live views and how the channel owner uploaded their live streams. So some of the live streams have views, but others, because of how they uploaded it, scraped as 0 views. So I need to look more into the different options that YouTubers have for uploading that information. Tags is our last vocabulary word. These are keywords that help the viewer find the videos on their YouTube channels. So when I refer to tags, I'm referring to keywords that are usually in the description. All right, so as for my research questions, I started this quest because I want to learn more about competitive analysis and machine learning libraries, and also the YouTube algorithm. So I wanted to figure out how do you figure out the YouTube algorithm? How do YouTubers do market research? Which metrics are most important while studying a competitor? What keywords or tags rise to the top when doing this research? Today, I'm still grappling with if I have enough information to prescribe that a YouTube influencer should increase their shorts. But as you'll see moving forward, I think that that's a major difference in each of these channels' success. Oh, going to the next slide. All right, so to put some names to faces, this starting at the top is Grant Cardone, Gary V, E.T. the Hip Hop Preacher, also known as Eric Thomas, Mel Robbins, Eckhart Tolle, Bryon Tracy, Tony Robbins, Patrice Washington, and this is John Acuff and Inky Johnson. So when I plotted these by subscribers, it naturally made these 3 clusters. So that is that. Going to the next slide. On this one, I did a box plot of the duration of each video that each channel has. So you can see the shortest video to the longest video here. And some interesting finds were that 2 of these have videos with a duration of 0. So that was interesting to me. I looked up one and it shows on their channel as listed, but you can't view their video. So this is an example of a video with a duration of 0. And going to the next. All right, so on this page, sorry, I think it skipped over. On this page, you can pick by channel, and it'll show you all of the videos and where they fall according to each of these charts. Right now, if you just hover over a few of these, you'll see that the ones that are breaking away from the herd have this hashtag shorts on their description. So I found that interesting. That's something that continues throughout the whole study. Justin, do you have a name that you want to choose to look at their metrics?
Yeah, how about Mel Robbins?
Okay, so overall, if you look at her information, you'll see that she mainly has videos with a duration just under 1,000 seconds. So that's about 16 minutes. So all of her videos fall within that range. You can also see that she has 3 lives with a 0 view count. And also here, you can go through and see the different trend lines. So with trend lines, I look for p-values over a 0.05 to show that there's a relationship between the 2 variables. So this trend line is definitely over 0.05. So that says that there's a relationship between the like count and the tag count. Up here, there in this blue group, there seems to be a relationship between the comment count and the tag count. All right, so on this page, it's dominated by, I separated this chart by duration as well. So on this side is videos that are 60 seconds or less. And then on this side is videos from each channel that are over 60 seconds. So Cece, do you want to pick a name for me to look at their metrics? So we have Gary V, Grant. Unmute yourself.
Can you pick Gary V? See, can I see
Okay.
that? Thank
So
you.
Gary V, also before I do that, you'll see again that the ones breaking away have this hashtag shorts on there. And then Gary V. Okay, these is his videos that are over 60 seconds. And I'll look at the trend lines. Yes, there's a relationship here between the like count and the view count. With this one, it doesn't seem to be, so neither of these 2. So yeah, I would go through these. And also if I go through just his shorts, I would look through here. There's significance there, significance. So yeah, this is also, you can play a fun game of like Go Fish and see if you can find some of the same videos in similar clusters. So that is that page. And then on this page here, you can also see that what's rising to the top are these hashtag shorts. A fun person to look at on this page is John Acuff. He basically dominates the bottom 100 with the lowest likes. All of these are his podcast. So that's really interesting, but he doesn't dominate it alone. Also, Grant has a lot, even with his shorts. He has a few down here. So this could depend on when he uploaded the shorts and when I scraped them. So I would have to look at that information, like when did he publish those videos. On this page here, this is, if I unclick this. So this is the sum of all the views across the 10 channels and the sum of the likes across all 10 channels. This gap here is occurring for each individual channel. I would think that this big gap between likes and views occurred because videos stay in circulation on YouTube, and possibly people that subscribe to these channels watch the videos multiple times after liking. So if we go to this next page, we'll get an even better look at the likes across each channel across the years. So I found it interesting that Gary V and Grant have like the same peaks and valleys. It's like almost identical, their charts. And if you notice, all of these channels are decreasing except for Mel Robbins. So I was informed that Mel Robbins has a TV show, and that may have influenced her popularity on YouTube. So that was really interesting to me. So I looked at her individual channel. I made projects for each channel, but I especially wanted to see hers and see like what changes has she made over like since 2019, because that's when I seen her really peaking, like starting to go up. So I see here that she definitely increased her views since 2019. It hasn't been, a consistent increase, but she also has increased her amount of shorts. Between 2021 and 2022, she basically doubled, and the year isn't even over yet for her. So that also made me want to look at across all of them. Was that a trend of like people making more short videos? And yes, so this shows that it almost tripled since 2021 here. So the orange is the 60 seconds or less videos. All right, so as I said earlier, I have a small sample group. So I can't say that I should prescribe that YouTubers should increase their shorts, but I see that some of the most successful channels in my group at least are increasing their shorts. All right, and here is a word cloud that I made with the NLP library through Python. And in closing, I do have 11 Tableau projects that I will be making public tonight, and one technical overview if there's any employers that want to know more about how I cleaned my data. I also have a GitHub account. Sorry, that's supposed to be HM Robinson. So not in. But that's all I have for tonight. So thank you guys.
Thank you so much, Holly. Any questions for Holly about her data?
It's awesome. It's actually true because during the COVID time, short getting up, and a lot of people do that for. So I think that maybe your search is pretty predictable, pretty good.
Yeah, thank you, Cece.
I
Very
didn't have
good.
a question
Go
in
ahead.
particular, but I just wanted to say great job, Holly. I
Thanks,
really
cousin.
found some interesting facts. Great job.
Thank you, Todd.
And also, I would like to say, I always wonder whether long videos were successful or short, but I can see that short videos do keep my attention because I can look at it and then think about it and go back. So thank you for that.
Thank you, thank you.
Great. And there was one graph that was very clearly 2020. It shot up. Oh, everyone's views shot up. And I think maybe that was due to pandemic and people having to stay at home for whatever reason. So yeah, thank you. And did you post? I just want to make sure you posted your Tableau public in the chat. Yeah, I see it. Perfect. So anyone interested in diving more into Holly's data, feel free to take a look at her Tableau public profile. Awesome. Next up, we have Cece.
I will contact you, Holly. It's great. Okay, I'm gonna share my screen. And okay, I start now. Hi, my name is Celianne. As a former owner of a nail salon in California, I handle all aspects of a business to include marketing and promotion, customer service, and employees management and accounting. Now I'm pivoting to data analytics because I like math and statistics. I'm very passionate and focused when I put my mind to something. In the boot camp, I enjoy writing programs using Python and practicing Excel and learning SQL. I love SQL, or the joy, inner joy. I have that joy in my my first page. And the most fun is working on the capstone. I love working with Tableau. I like the challenge of taking a boring topic. I thought that Wildfire is a boring topic, and I like to make it the most appealing story by using Tableau. For my capstone project, I left California 6 months ago to move to St. Louis, and I realized that it's really green here in Missouri. It's so beautiful to me. There's so much rain here. The air is so clean. It's so much rain compared to California when I left. In contrast, California is very dry. I say there is not much rain for many years. There is not enough water in the lake. The pine trees up in the mountain are very dry. Everyone couldn't afford to have much grass because such a high maintenance. We have to turn everything to rock, and we took all the grass. And there have been so many wildfires lately. The air is polluted from smoke and dirt. Therefore, I decided to do a capstone project about the dryness in California. I would like to analyze the cause of the dryness and how it relates to the wildfire in California and the West. So I am using Python programming language to clean the raw data. Then I'm using Excel to create math equations for sum and average. And for graphic, I am relying on Tableau to create my project dashboard and charts. And here is my capstone project. Is the first page is my, and I want to show you my intro. So just like I say, in this project, I will illustrate the correlation between the rise of wildfire and the drought taking place in the Western United States. I will cover all these questions. Where is the driest area in US? What are the top 7 wildfire states? Is California one of the states having most wildfires in US? What is the trend of California wildfires? And what are the top months of wildfires in California? And the last but not least that I mentioned from the beginning, that how different is the rainfall index between California and Missouri. First of all, I get my data, most of my data, many sources from National Interagency Fire Center. And because I have so many sources, that's why I have to do the while loop and enter the CSV file name. And then I read it, and then I will just create the set to put all the column I need only, and change the name of the column to make it clear. And then I will check new on everything, and then I will split the day and get the date only for my column, and then I get the month out of the date for my different for the month analyzed. And then this one I use the month name, so that's why I use the month string name type. And then I will save the data, the table into my clean data, clean table, clean source. Then after that, this is my source, my file after I clean and I source them, so that way I can do it later, easier when I put in my Tableau. And the next one, similar, this is just a smaller, that's why I just clean it up and check and kind of similar, but this one I don't have to do the while loop. And I have the table like this, and I use Excel to sum for my drought information. If anybody have any question, I can answer. We can go a little bit quick. Okay, after this, it will show you my data visualization. My first graphic is a map of the United States, and it shows the drought, the driest area in the United States. And as you can see clearly that I make it from brown to green, so that the brown area is the area that have no, it's nothing. That means everything is dry and not normal here, because everything in this area is, see, California have 0 of nothing, when New York have 100% of nothing. That means they don't have any drought, anything. And we have 5 degrees of droughts. We have D0 abnormal dry, and D1 moderate drought, D2 severe drought, D3 extreme drought, and D4 exceptional drought. And I would take the sum of D3, D2 to D4, and then I would create a second layer for the circle, and then we'll see which state have the biggest circle. And we can see Montana, Oregon, Utah, California, and Nevada, and most of the states here in the West. So just a little bit general idea, so you know what area we have a lot of dryness. And the next one, I want to show you the correlation between the drought and the wildfire. And you can see that California has the top of the line, and it's actually very dry here. It was very beautiful state with a lot of forests and lake, but they're getting drier and drier every year, into 20 years lately. That's why I get a lot of wildfire. And you can see next to that, Montana and Washington, Arizona. So they're all getting drier and drier. Utah dry, but it's because it's red rock area. So it's kind of like there are no forest or tree in some area, that's why. And not many people here, so like California. Next one, I would like to show you the wildfire history, so that way you can see a little bit in 21 years, what area have more wildfire. And the darker color is indicate the more acre burn. You can see like California, like really big dark one, and 1 year in Texas. In California lately, a lot is getting darker and darker at the end of 2021. So you can see how like 2.5 million, wow, acre burn. The next one, I would like to show just a very original chart that I like. That's the whole table of data, 250,000 lines of data, and it's in here. And you can see where is California in 2020, it's 4.2, almost 4.3 million acre got burned. And you can see in here, California in 2021, Washington 2015, 1.7 million, Texas. So you can see basically all the information that you need, what year and how many acre. And most of them is all the state in the West. So I want to zoom into the top 7 states that get a lot of wildfire per acre burn. This is the chart, the bar chart that I show in here is each slice is indicate the number of the acre burn every year of each state. California, when you click it here, you can see every year. If you click on California, you can see the whole thing every year, just like that. And this, you click on only here, you can see that year 2020, like how much it burned, like I show. And the bottom chart, line chart, is the reflection of the first bar chart, but it showed a total of 7 states. For this 7 states in 2020, it burned almost 7.7 million acre. Only this 7 states. And last year, 5.8 million, something like that. And the year before, a little bit less, and it's back. So you can see the trend is go more and more to the end of 2021. Let me, I want to, and next I would like to show you the bar chart of the total acre burn of each state in the last 21-year period. And I sort them to see that which one is the most. And you can see California for the 21 year, it burned almost 21 million acre. It's a lot of money. Idaho is the second, and next to that, Oregon, Montana, Washington, Arizona, and Texas. So that's the general idea. You see how much the top 7, the West, burn so much lately. Arizona get up more and more lately. That's why it's to the 3rd or 4th. Now I would like to show you the California. Rising wildfire in California, because I'm focused back to California because it's the top state that had the most acre burn in the last 21 years. And you can see the trend, it go up and up and up to the roof. So that's why we say that California is like the top of the United States and the top of the 7 state in the West. Why? Let's check why is what year, what time of the month, or what time of the year that it get burned so much. And then we can see California here. California is a beautiful state with lake and mountain and stuff, but it getting the lake getting drier and drier. A lot of forests. And then we can see every time we go up to Big Bear, anyway, we can see the lake getting less and less, all the house built up there. Now, instead of on the water, now it's on just the dirt. And you can see, you can see California is almost fire all year, except only 3 months of the year, February, March, and April. So almost every month. And the top is from August to January, which is in fall and winter. Why? Because you know why? Winter time it's cold, it's supposed to have snow and rain, right? But California is so dry. They don't even have much snow and rain. That's why you see the top of the line is November. They burn it sometimes. It burns so much that we wait for the rain because we cannot fix it. We have to wait for the rain and we wait for the rain and sometimes there's no rain. And that's why it keeps burning for a long time. That's why it's getting bigger and bigger. And that's why a lot of acre burn. Now, that's why it's make me, that's why when I moved here, I just amazed because how much rain it here, because like couple of days rain. So I wish that California that way would be less fire. And let me compare the rain index between Missouri and California. And would you believe that California last year only 5 inches per year. Average is like 12, but it's getting less and less and less lately. And Missouri have 57. Average Missouri is around 43 inches a year, but last year it's had a lot of rain. And this year it's 49. So Missouri this 2 years in the row, it have a lot of rain. That's why when it came here, it just amazed me how much rain here. It's a average rainfall in index in US only is 31 inches, but Missouri like 49 now. For normal index is 43 for Missouri. That's the average for Missouri. So that's all you see. That's why I talk about Missouri and California rain, and that's why I talk about wildfire. So let's see, let's go to my conclusion, because all of that, it I make a conclusion. The Western states are getting drier and are having many large wildfires on the more frequent basis. It's getting more and more at these last few years. That's why we draw some caution right here. Do not be naive when travel to California or Washington or Oregon and other Western states. The tree is so dry that when you touch it, you can feel it, the texture, and you look at it. Every time we go up to the mountain, we're wondering if it's the burn or something, a fire, we have to find a way to get out, because it's kind of scary. It's kind of sad. And or when you research real estate or other investment opportunity, you have to make sure that the insurance company will sell you what price and everything, because be cautious of that, because like someplace maybe they will raise to the roof the price for the insurance. So, and make sure who know they would sell or not sell when the wildfire that much. Concern how insurance companies will deal with the rising rates, because it's so expensive of the wildfire in California and the West. It remind me about Florida just last week, and then it's $100 billion for just them. Should we buy real estate there? Will real estate price go down in California in the next year? In the next few years due to the wildfire situation? Should we move out of California while the market is still hot? It's all kind of thing that when I got into this field, it's just so many analyses here. So it's amazed me, because I thought it's boring when I got in here, but when I got in here, I learned a lot. The next step, I would like to search for California drought and wildfire data for the last 100 years, and maybe I will search for how much its cost for wildfire in California and the West. Let's see, we have time for this. Can we take a look at this real quick? Because I found some video that show the drought, show the wildfire in California for 100 years. A really quick one, so just to get more information. It's amazing. This one, Holly, you talked about this before.
Yeah, it's so pretty.
Yeah, I found it a couple of nights ago when I was searching for 100 years. But you can see. It's going to the million number, like getting bigger and bigger. So that's a little bit illustration of that. And now I finished my capstone project, and now I survived. I touched the water, I tested the water, and I survived. Now I'm gonna jump in the next time. And I want to say thank you to Savvy Coded and the team. The program is great. I learned a lot from the cohorts and everybody. I learned, and it's great that we have a very close connection with people, with everybody in the class. And I thank to Justin for helping a lot. For in the beginning, you always be there for us. And thanks to Lori, like very strong and very good from the beginning. I was scared, and then I got in, and then it's good. A lot of support. And thanks my teacher, Ashley. She's so sweet and patient and nice. She's such a patient. Sometimes we were so getting so confused with all the study with Python, and we go back to the class, and then we ask some very question that very bad question, like we don't even know what we're asking about, and she very patient and show us very good to explain to us. Her patient is very, I really appreciate that. And at my capstone, she helped me a lot too, when give me ideas and stuff like that. And I want to say thank you to Kelly, Moisha, and Nicole, that three ladies that work for the LETC program that give the fund to go to in this program. And thank you so much, everybody in the class. You guys awesome. Thank you.
Thank you, and very eye-opening presentation. And just seeing how large the fires have gotten over the last 15 years is astounding, especially as it becomes more developed. So fires now are destroying a lot more homes than they did 100 years ago. Really, really sad. Any questions for Cece?
You did so good, Cece.
Thank you. It's so funny because when I get into this topic, it's getting bigger and bigger. Now I cannot stop. I have to go in more and go do more because it's getting bigger and bigger. I expand it more and more. And then Ashley told me, stop putting any graphic in there. You have enough. Just like just too many. Thank you so much. You guys, now I can stop my sharing now. Or any question?
All set.
Thank you.
Cece, did you want to post your dashboard in the chat? Your Tableau dashboard in the chat? Okay, great. Next we have Bryon.
In the chat?
In the chat, yep.
Yes, thank you.
Okay, give me, oops, that's the wrong one. No, yes. Boom. All right. I haven't shared the screen yet. I apologize.
No worries.
You're already getting a little bit of a glance. Oh, where's my story? Oh. All right. Oh my goodness. Let me stop sharing.
Rewind, like the old school rewind button with the VHS tapes.
All right. Back to the screen. I'll try to make this quick and painless due to the fact that my Wi-Fi puck is about to die on me.
No worries. We look forward to seeing it.
All right. Good evening, class. My name is Bryon Doherty. Right now, as of now, I am working in IT. Before IT, I was working for security for the last 10 years. Before starting security, I had joined the military. Now I'm an Army veteran. I had joined Fort Riley, Kansas, the Big Red One. As you guys see my opening, I thought it was dope. And second, I was in the photo. So I thought it would be an interesting topic. Before I get started with my topic, I want to say that I might get choked up because this is a very hard topic for me due to the fact that it's kind of personal. So next slide. These are all the references that I had used for my capstone. Some of them isn't data, but what I have been through, which comes up to my data. I decided to do this project due to a recent suicide. Specialist Casship had passed away in 2017. He was found dead in his car. And this is really a dedication for him. And the most recent suicide, Specialist Rush, also a friend of mine that lost his life, was found in the woods. These are my unit citations, who I represent when I was in the military. I represent the Big Red One, the 82nd Engineers, the Blue Babe, and the 163 Dragons. As you can see, there's many faces of me. I joined in 2012, got out in 2016 with an honorable discharge. Look pretty snazzy right here. And let's get started. Part of my capstone, I like to talk about what put me in my mindset. I had deployed in October, very shortly after the Kuwait bombing. I had deployed to Camp John, Kuwait. I had spent 9 months overseas with Kuwait, and then coming back for redeployment. Our airport, the airport that we was transporting to, was attacked in Istanbul, so it delayed my re-entry into the United States by a week. And with that, is so much into that in real time. It's just insane. Last month, I want to put this on here. Last month was Suicide Prevention Awareness. I take suicide very seriously due to the fact that I have suffered with depression and suicidal thoughts. Next slide. Oops, I'm so jacking up. The bubbles represent a veteran's mindset. What goes through the veteran, or even the military member, throughout whatever they go through. You'll see in the bubbles, you'll see something like staff duty. Staff duty means you work 24 hours and you don't leave until somebody relieves you. So that right there, it could be a lack of sleep. Your relief don't show up. It races the mind. Um, being flagged was one of the main problems in the military. Being flagged is you failed on the Army standards, so they you can't do certain things, like you couldn't go on leave, you couldn't get promoted, you couldn't excuse me, uh, you couldn't get promotions, you couldn't get awards, and
Did you freeze?
change it. It depends on what you could go through with the orders. The orders could be silly, completely silly, but you have to do them anyway due to orders. PCS stands for permanent change of stations. So say for instance, if I was stationed at Fort Riley, Kansas, and I had got orders to move to Fort Drum, New York, I had to be there at a certain day at a certain time before I become AWOL, which stands for absence without leave. Deployment was the biggest one. Due to the fact with deployment, most of our divorces came from deployments, which leads up to anxiety, and depression. And that's where we have more veterans drinking, doing drugs, while still in the military. This is the data. This is the data I had got from once a soldier, as well as the VA. As you see, there's some areas that's dark gray. There was no actual data into it. These are the suicides at age 18 to 34. With some of the data, if anything in their books was below 10, they don't record it unless it's more than 20. And unfortunately, Specialist Baca and Specialist Rush fell into this category. Suicide between 35 and 54. Most of the suicides, the states were Texas, Florida, and California. With that being said, Florida and Texas were the states that most of the veterans had joined the military in. Most of the people I met were from Texas and Florida. Age 55 to 74. Actually, this range was the highest deaths out of all of them. From age range 55 to 74 was the highest age range. As before, not all of them had complete data, such as Kansas, Montana, Colorado, and Vermont. This data with 75 plus the data with 75 plus, I don't believe it was 100% accurate, but it was still on the books due to the fact that anything over 75, it could have been natural causes, but even the body could take stress. Overall, Texas and Florida has tied with the same amount of deaths, with California seconding it, which Specialist Baca coming from California, and Specialist Rush coming from Texas. Overall, this is not one suicide a day. These are multiple.
Wow.
I had, unfortunately, I went to put the national hotline in. For anybody that need help, call the suicide prevention hotline. Or if you don't feel like pressing too many buttons, you can always press 988 for the suicide crisis. With that being said, that was my capstone. Thank you all. Like I said, I wanted to hurry up and get this done before my puck died on me, and I hope you guys stay safe and you guys have a good day.
Thank you, Bryon. Super eye-opening. Does anyone have any questions for Bryon? Questions, comments, thoughts?
Good job, Bryon.
It's-
Like
Thank you.
those.
yeah, now we learned so much. I'm so sorry. We learned so much about that, and that yes, we thank you for sharing that, Bryon.
Great. Okay, and we have Evans. Evans, are you setting up? Yep, here we go.
I'm sorry. Once you click on share, the mute button doesn't show. Okay, Evans, Prince, Daniel, Prince Evans. I am a family man, teacher, an entrepreneur, a researcher. I'm currently finishing my year at University of Missouri. I'm a lover of life. I've taught for 5 years before University of Northern Iowa, UNI, for my BA and MIS, and the same school for my master's in instructional technology, and where I studied training and such like things with presentation. I have started various ventures. Some of them were fruitful, some of them didn't last long. And the way I knew about this program, it was through my friend, and it's because I've been wanting to change trajectory with my career, and for the last a year or before, I wanted to do data analytics so that I can incorporate it into research or whatever I'm doing. And that's why I'm here, and I've had the opportunity to do this. I have learned immensely. It's not going to be reflected in this presentation by all means. This is just a snippet of it. I made my presentation simple because I was hurting. Last week, this week has been hard to me because I got hurt while working, and then at the same time I feel aches in the body, and so let me go to. And so my presentation is really simple because I believe that I need to show it so that people can understand it, can understand. So this, I had a lot of data, but I just chose 2 things to present on because, I mean, we've been told like we need to keep it under 20 minutes, but it's okay. It's global gross income versus gross savings, like do higher earners save more or not? This is what it's going to be answering. And this data was gotten from a global international monetary fund. And so what, what this shows is like the Global Monetary Fund groups income earners into 4 groups. We have high income earners, we have low income earners, lower middle income earners, and upper middle income earners. This is how they save. This data is like from GDP, it's cumulated by country and continent. And so what this shows is like high income earners save more. It's kind of logical. Low income earners save less. Middle income earners try to save as much as they can. And so this is savings by continent. And, you know, it amazed me just from looking at it. I never knew like Africa saves much than the US, like has more savers. It's more savers than the USA. But I believe because of this just shows this way because in the US, people save in various places, like there's government savings, 401k and stuff like that, probably not included in this data. And also things like stock and other saving ways. And so I think that's why it reflects this way, but it shows that Asians save more, Europe save some, and then the rest of them save less. And so this is the same, this is grouped to continent and countries. And you can see how individual countries save. Like this country here in Africa saves quite a bit. But at the same time, we have those who are on the other side in the deep hole. They don't save much, or I don't know what's the reason, maybe war, maybe other things. This is what it shows, like every single country in the world is represented here and how they save. And this cluster of high income groups and continent savings, income groups, continent savings. So in the higher income group, Europe saves more than any other countries, towering other countries. In the lower income cluster, Africa saves more. In the lower middle income cluster, Asia saves more. I think it has to do with the number of people. In the upper middle income cluster, Asia still saves more. And so this is, I decided to just pick a little snippet of data to just for the purposes of this presentation, but I have done a lot with this. What I did, I went back from Python to Excel to SQL. I actually learned a lot of SQL queries, and I did a lot of coding. And this, what it shows is like loading up data into countries DB. This is one of the CSV files. And what I was trying to do here is loading multiple files, but for now it didn't work, but I think it's possible. So that's a project that I have to work on. And so once I loaded, this is how it looks. All these I loaded in the same time to work. And so I decided to just go with countries and economic status 2015. This is the two tables that I use, but I can combine any, can do a multiple combination of these tables using inner joint, left joint, and all that, except a couple joints that are not supported in SQL Server. And so I just played around with the data to just see what it looks like by picking a single item. There I accumulated data. All the cities in the world have a population of that. Just the cities, not the whole world. Just the whole world is about like 8 or 9 billion people. But all the cities in the world, almost 1 billion people. And so I decided to do some inner joints there, an inner joint, just to see what the data looks like. But I didn't use the language data for languages of different countries. I used that. Yeah, I did 3 tables, combination of 3 tables. And so I came into the project, which I just used 2 tables. First of all, I had to, I do select all. And then after I have all the data, I go in and alias this and pick the different, whatever data I want to use in the table. And so because when you create a table, it doesn't store itself because the query is running. You have to find ways to store it. And so I created the table first, and that the data frame of the table in the SQL Server. And then I selected the data with a single country. These things, we pick it by one country. And then insert into the data frame. And then yeah, and then download it. But what this shows that it shows there is no countries, whatever data, just for you to see that I exported it from SQL. It was successful. And then here it is sitting here. So from here, that's when I had to load it up to Tableau and do the analysis that you just see. So kept on playing with it because I'm fascinated with it and want to learn more. And I have more projects coming up, like this one is coming up. I'll be working on it more once I get better. And that's all I have. And I have other projects that this project, I did it in like 3 days because I had worked on a pizza project, I finished. I worked on another pizza project, I finished, but I thought that they weren't that intuitive. So I decided to do this. And this didn't have coordinates for to show the map. I'm thinking probably I'm gonna keep working on it so that I integrate that into the display, into the presentation. Otherwise, I enjoyed everything with my class. Special appreciation for everyone that has been instrumental getting me here, especially Justin Treadwell. If it wasn't for you, I wouldn't be in this program. You really fought for me. Ashley Python, Ashley Excel, Ashley SQL, it helped me a lot. Ruby SQL, Ruby Excel, Ruby Games of SQL, Laurie Wilson, and the whole class. I really, truly appreciate you. Thanks for the interviews and listening to me, and be blessed. Thank you so much.
Thank you, Evans. And I know you had the pizza project. So if they're still in your Tableau public and you want to post your Tableau public profile in the chat, we can take a look
there
at
are two of
those.
them. But
Oh, good.
how did you see this one? Yeah, the pizza one was kind of